Okay, and for now, I'm just going to mute everyone temporarily so that it will be fairly quiet during the lecture, and then you can unmute and ask me questions after. So I know that some of you are having trouble finishing exercise H. I know it's not easy. It's always hard to teach things where a little bit of guesswork is involved and kind of intuition. So the point of this is to give you a hint, some hints so that you can get this right and you don't have to stress about it. To kind of give you more insight into the kind of educated guess you want to make about making your range of data to mark your graphs with. So I think reading the graph, we can go back to that, but I think that that part was pretty clear. Not too many people were asking me questions about that. You just, if it asks you for what's the vapor at 72, you find 72 on here. Of course, you guys had different values, but you find 72 on here, and then you read it up to wherever line. So if it were ethyl alcohol, you'd read it up, until it gets to here, and then you read it across and read what the vapor pressure will be. So reading the graphs, I think people didn't have too much of a time with, but I want to point out again, see how a graph is properly labeled. The numbers get bigger as you get farther from the origin. So they get bigger, and they get bigger in even steps, and they're nice and round numbers. Like 100 is a nice round number, easy to label. So it goes from 0, which isn't labeled here, to 100, to 200, to 300. If you can go by hundreds, that's great. You may just take a guess and see, hey, can I go 100 by 100 and fit this on my graph paper? If so, great. Or can I go like 1 by 1 or 10 by 10? Here they went 10 by 10. From -10. So notice this didn't start at 0. It doesn't have to. Then 10 more from 0 to 10, then 10 more from 10 to 20. If you can do hundreds or tens or ones, that's great, So you can always try those. Now, what I wanted to give you here when I did this was I wanted to give you kind of a like mathematical way that you could narrow this down. But really what you're looking for is a way to divide up the boxes that you have and use most of them so that you can then graph your data. What temperature is considered room temperature? Room temperature is about 20 Celsius, or 20 Celsius is around 70-ish Fahrenheit. So yeah, we'll learn more about metric variables. That's going to be like starting next week, we're going to heavily go into metric variables. And next week is going to be a big week. There's going to be a lot more content than this week. Right now, I just wanted to make sure everyone's got the software that they need. And I didn't want to make it too heavy because people are still getting acclimated to what's going on here. So I didn't want to have a large amount of work when everyone's just trying to download their Adobe Snap app and make sure that they have their computer ready and all of that. But next week we'll really start with the lessons going a lot faster, but it'll be about measurements, and we'll talk about Celsius. So okay, so here, we want to look at the number of divisions we have available. Now, on the instructions, it says you want to use 2/3 of your graph. That's a good rule of thumb. You don't have to use it all, though. So, for example, here on the horizontal axis, I count 11 boxes. 1, 2, 3, and so forth, till I get all the way over here. There's 11 boxes, but I probably will end up wanting to use 10 boxes, okay? Just because dividing by 10 is usually a lot easier than dividing by 11. So maybe I want to use 10 boxes. And I do that in the example as well, one of them to show you. Here, I've got 6 boxes. It may be convenient to use 6 boxes. I think this is where I showed it. But it's usually more convenient to divide by a number like 5 or 10, or some nice round numbers. The goal here is to get nice round numbers. So when we're looking at our values here, on the low end, they're 0.2 to 0.02. So you definitely don't want to choose 0.202 as your end, okay? That's just too specific. You want very round numbers that are easy to label on your graph. So you may start at 0.2, okay? That would work. Yeah, or even easier, since, you know, 0.2 is fairly close to 0 compared to this one, you could just go 0 to 1, you know. So if we go 0 to 1 on this, yes, we're a little bit lower than our first point here, but pretty close to our highest point. And you know what? This is really easy to divide into 10 boxes, right? We divide this into 10 boxes, so 0 to 1, which that range, I guess the way I wrote this isn't very good, but the range is 1. We're going to divide, I'll just put a parentheses here. We're going to divide 1 over 10 boxes, okay? So that means that each box will be 0.1. You can just, you know, you can put in your calculator if you don't feel comfortable doing that mental math. Whoops, I stopped my screen sharing. Oh man, sorry about that, guys. I'm still getting the hang of doing this again. I was really good at it by the end of last semester, but okay. And now I'll screen share again. Okay, and I'm going to share my full screen projector. Okay, so got my calculator right here. And so I may want to divide here divide my one range. So my range is 0 to 1, which covers 1, and I'm going to divide it by 10 spaces. Divide by 10 spaces. So each space is 0.1. That's very, very convenient. Now you could, you know, you could have just guessed at this. That's fine too. You could have said, okay, what if I started, you know, even if I started at 0.2, what if I did 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. Yeah, that would have worked. In fact, we can use all of our boxes here. So we could start at 0 here. Oh, this is for our Y range. Whoops, I messed up here. So we don't have 10 boxes, right? We have 5 for the Y values. Okay, so scratch that. We're going to do 5. So it was not totally clear, sorry, but we'll do 5. So if we divide by 5 boxes, 1 over 5 boxes is going to be 0.2. Now notice I did 5 boxes here, not 6. This is even though we had 6 available, right? We have 6 available on the y-axis. It's because dividing by 6 is not going to give me very nice numbers here. But dividing by 5 and 10 and you know, and round numbers like that, they usually give you nice and easy numbers. So I can go 0 here, and then my first one would be 0.2, and then my next one would be 0.4, and then my next one would be 0.6, and so forth. Till I get up to 1. And this is nice because it gives me nice round numbers and it covers my entire range. Of course, my first point when I'm graphing it would not come until, you know, right here. So I'm kind of wasting this first box. So, but that's okay. At least we're covering most of the graph. We want to cover at least 2/3 of the graph. So just because I'm not using this space right here, that's okay, because I'm going to be using this space all the way up to like right here, which is most of the graph. So that's good. So now I have my X values range here. So for my X values range, again, I need to choose nice round bookends on the end. So I kind of showed you that with the second example here. So here I just turned out to get something that was really nice to divide by 11. I got 0.1 per box. That with my example. Here my range was 92. Not a very convenient range to divide into 6 or anything really. So what I did was I said, okay, I'm going to start at 0. You don't have to start at 0, but you can. And I'm going to go up to 120 because 120 is slightly above my higher value. And that gives me something I can really easily divide by 6. Right? So for this example, I want something that I can easily divide by 6 or 5. So I might start for my x values here, or rather by 10. I keep mixing them up, but on our x-axis we have 11 boxes, or we can use 10 of them. So here, maybe I want my range to be from 0 on the low end, and I choose 0 because this number is quite close to 0, the 0.00995, compared to 0.048. And maybe I just want to go a little bit higher than 0.048. So that would be like 0.05, let's say 0.05. Okay. All right. So that's my range. So the whole range covers the values of 0.5, 0.05. So I take my 0.05 range. That's the range I'm covering. Oh man, this is so slow. My new computer parts come today, so I'm hoping I can fix my computer before my powerful computer before next week, so we have a better experience. Now I could divide this by 11, but that's not going to give me very nice round numbers. How about I use 10 of my 11 boxes? So I'm going to divide this into 10 boxes. Okay. So if I do that, you can use a calculator if you want. We're essentially moving the decimal point over by 1, but why don't we just break out our calculator anyway? If you're still getting comfortable with numbers, it's okay to use your calculator. Just think before you just punch away, make sure you're thinking about what you're punching. But if your calculator can help you get more accustomed to the numbers, that's great. So we're going to do 0.05 divide by into 10 pieces. 10 boxes. So we get 0.005. Essentially, we moved the decimal by 1. So each of our points is going to be 0.005. Now, labeling each of these could be quite difficult. So maybe I'll label every 2 boxes. So if I multiply this by 2, that will give me how much is 2 boxes? 0.01. Wow, that's very nice, right? So I can go 0, maybe if this thing decides it wants to write, 0.01, 01, and that would be this box right here. Now, if you can write very small, you could label this one 0.005, then this one 0.01, then this next one is 0.015, and this one is right here will be 0.02. And you can see that if we continue to go to this, we're going to get to about 0.05. And so we'll be able to cover our entire range. And so there, I basically solved this problem for you. That's okay, as long as you struggled with it a little bit and tried. You always get a benefit by trying, even if you struggle with, especially if you struggle with it a little bit. But then you want to be able to know you're right. So this is the one way to do it. The problem with these is there isn't just one way to do it. You could have labeled these a different way, but what you're looking for is nice even divisions so that every box that you label is the same distance from the previous box. So here, from 0 to 0.2 is 0.2. Then the next jump here is also by 0.2 to 0.4. Then the next jump is also by 2 to 0.6, and so forth. Here, every 2 boxes is 0.01, then 0.02, then 0.03. And these are nice, easy to label. You don't want labels that are like 0.167, because there's no way you're going to be able to accurately graph numbers if your labels are so weird like that. So that's why when our considerations when we do this is we choose a range that we can easily divide it into pieces, and we choose a number of pieces that we want to divide it to that's easy to divide things by. So here, yeah, I could divide 1.1 by 11 pretty easily because I get 0.1 per box. But you know what? You can divide almost anything by 10 pretty easily. A lot of things by 5. And so you do have to do a little bit of trial and error sometimes. And you get this kind of exercise also builds your sense of how big and small numbers are, which is going to be really useful in this class, and how big and small they are compared to one another. And so this is why I like to start with a little math review, because we'll be doing a lot of math in this class, especially starting next week. Okay, now moving on to making a full graph. So here's the problem where you are meant to make a full graph on your own. And the issue here is that you are just given a series of data. So you've got to do everything you did in problem 2, but you also have to graph the points. So first of all, the volume is going to be on the y-axis. So we're going to consider our range for the y-axis here. All right, so for the y-axis, I'll just call it y. For the y-axis, we're going to go, so on our lower end here is 2.01. That's our lowest number. And our highest number is 10.7. Okay, let's count how many boxes that we have available. So that's what I did first last time. Of course, if you're making your own graph, you may have as many boxes as you want. But in terms of big boxes, I'll count them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So 13 boxes. Now we're probably not going to use 13 boxes, okay? 13 is very hard to divide things by. Volume is on the y-axis here. So you can see it, actually they've already labeled the axes for you. They labeled the y-axis here as volume. So you didn't have to guess at where you're going to put that. The pressure is going to be the x-axis. So these were written in that way, it just turns out. Yeah, I know traditionally in math class, you're going to want to write your x values first and your y values in the second column, right? This was not done here. But in this graph, they're just telling you to put the volume on the y-axis. So we're going to say this is going to go on the y-axis. But that was, I see what you're saying there. Now, okay, so when we're making our range, we want something that can divide into, like, well, maybe not 13, but maybe 12 or 10 boxes. Well, look at this. On the low end, we're kind of close to 0 here compared to 10. So 2 here is kind of close to 0 compared to 10. So we can start with 0 if we want. That seems like it will be easy. And then maybe our range goes up to like 12. Okay, and if we divide those into 12 boxes, well, then every box will be 1, right? So that's the kind of situation that you're looking for here. You want something that comes out very nice and easy. Now, if you didn't want to do the fancy math that I showed you, that's okay. You kind of count these out and think about it. Oh, it looks like, counting by 1 might be a good idea here. So let me try it. I go 0, and then 1, and then 2. And if I keep numbering 1 by 1, once I get up to the 12th box, I'll be at 12. And that will cover most of my data. Like a range of 0 to 12 is really good. So I chose a range of 0 to 12 here. And I had 13 boxes, but I'm only using 12 of them because 12 is an easier number to divide by. So I had a range of 12, and I'm dividing it into 12 boxes. So that gives me each box being 1. One per box. One per box. Okay, that's great. That's really easy. I want numbers like that, like 1 and 10 and 100. Those are really easy to label. So you can either do it in the formal mathematical way. I just did it, kind of take a guess and see, try to see where you can divide something and get a nice round number. Or if you look at the numbers, you might just be able to kind of tell that, hey, if I go one at a time, 1, 2, 3, 4, 5, I will cover my entire range of data here. Make sure that your numbers are going from lowest to highest, like I did. Don't go from highest to lowest. That's confusing. So don't start at 12 and go 11, 10. That's confusing. You want to get bigger as you go further on each axis. Now here on the horizontal axis, I also have 13 boxes. I think, let's see, I'll count them. 1, 2, 3, 4, 5, 6. Oops, no, that's not 6. This is 6. 6. 7, 8, 9, 10, 11, 12, 13 boxes. Now, I'm going to let you, maybe you guys can answer in the chat or by voice. Do you see a way, looking at these numbers, that we could divide these into 13 boxes and get a very nice round number?
I use 100.
100, right? Yeah, by 100, exactly. So sometimes you can just visually inspect it. If I was doing this, the formal mathematical way that I taught you, for the x values, we could say, okay, our lowest value, 250, is close to 0. So I'm okay with starting at 0. And I'm going to go up to 1300. So now, it just turns out that this range is good because we have 13 boxes. Usually, maybe if we didn't have 13 boxes, I'd start to think about going from 0 to 1500 because that would give me, nice round numbers to divide by. But because I have 1300 as my range, and I just so happen to have 13 boxes, that makes for very convenient numbers. So I do 1300 divided by 13 boxes. Oh my God, this lag is driving me crazy. So 1300 divided by 13 boxes, this means 100 per box. Okay. So yeah, that's a very nice way to label your graph. If you can ever get, ones or tens or 100s, that's really nice. It's very easy to read. Okay, so you might have just been able to visually inspect these numbers and figure it out. Oh yeah, it looks like, if I go by 100 by 100, I'll have enough room. Sometimes you'll be like, oh man, I didn't have quite enough room. I'm going to have to make my divisions 150 or 200 instead. But yeah, that's what makes it, really easy. So we're starting on this axis, we're starting at 0, 2. This is going to be 100 and the next one will be 200 and so forth. And we'll just keep going till we label it across. So I'm not going to label every one. I'll be 200, 300. I'll label this one 400 since my writing is really big, but each box is 100. Okay, that's what's important. So this is 100. Let me get my laser pointer out. So this is 100. This one is 200. This one's 300. This one's 400. This one's 500 and so forth. So now we can start to plot our points. Okay. If I'm plotting the, if I'm plotting the pressure 250 torr. So 250 torr is going to be right between 200 here and 300. So that's going to be right in the middle here. And this is going to be up to 10.7. So maybe I'll label a couple more near the top here, even though it's kind of difficult. So this was 12 up here. This one is 11, this line. So this one was 12. This one is 11. This one here is 10. So our result here is going to be between 10 and 11. So we started right here between 200 and 300 on the pressure, and we go up to between 10 and 11, and we want to be a little closer to 11 because it's 10.7. So we plot right around here. So half, whoops, my point is kind of too big, but you get the idea. We're between 2 and 300 on the pressure, and then we're between 10 and 11 for the volume, closer to 11. And you'll keep doing that. So for 350, you'll move up from between 300 and 400. You'll go up to 7 or so. It'll be somewhere around here, and so on. And so I won't plot them all for you. I think you can move forward from that. But now I just want to open it up and see, are there any questions about exercise H that you want to know a little bit more about?
So when we do the rounding thing, does it have to be like even, or is it okay just like for the number 2? Is it okay if we just jump from 202 to 200 and then 936 to 940? Is that okay?
For your labels?
Yes.
No, your labels have to be the same distance between each other. Okay.
I mean, yeah, but is it okay? Is it okay if it's just like when you round them off, but they like the distance from each other is the same, but it's just rounding off is just a little bit too close, like because you did like the 200 and then to 1. So is that okay if I just made it like 200 and then 940?
You don't want to label your axes like that. You want nice and even labels to your axes. Your points is different from your axes. So notice here, I'll go back to the graph. So notice that there is no label for 250, for example. Okay, there shouldn't be, because our labels are going 100 by 100. The way we indicate 250 is by where we put the point. So down here, so right here, now you don't have to label every tick, but if you label what you can fit, like my writing here was kind of big, so I couldn't fit 200, but each box represents the same. It represents 100. Now 250 is right between 200 and 300. I don't have a label for 250, nor should I. I should put my point in between my labels of 200 and 300. So you can see it is in between. It's right here between 200 and 300. I also should not have a label for 10.7. I want my labels to be nice and round, one at a time here. 10 for this one, 11 for this one. The way I indicate that the point is 10.7 is by where I place it. I place it closer to 11 than to 10, right? Basically, you could divide each of these into parts. So this line would be 10.2, this one would be 10.4, 10.6, 10.8, 11. So 10.7 would be right about here. Did I address your question there, or was I off the mark on that?
I think in a way, but yeah, I was just asking if like the distance and range from everything is just the same, but the rounding from the range, like the original range, is just a little bit off, but not like a lot.
Yeah, you can have so maybe your divisions aren't not so nice. Maybe they're not 100. Maybe they're 80 for each box or something like that, or 70. That still works. Okay. Yeah. As long as what I'll be looking for is that the labels cover your entire range of data on the graph, that they are the same for each box, and that they allow your data to cover most of the graph. So your data isn't squished into a corner.
Yes.
So for example, right here, if I decided to do 200 for every for every tick mark here. Well, I would get to 1300 right about here. And then the rest of my graph would be worthless because there's no data there. So that's not ideal. You have your data be able to spread out so you can read it better. Yeah. So that's fine. Your labels do not have to be exactly the same as mine, but they should be even. Every box should represent the same amount, and they should be somewhat able to read. If your labels are like, this one is 0.136 and the next one is 0.272, and then those are like really hard to read, and you don't want that. You'd rather have 0.2, 0.4, 0.6, like that. Did that help?
Yes, thank you.
You're welcome.
Professor, I have a question.
Yeah.
Yeah, with regards number 3 as well. After plotting all the data, I don't get the perfect diagonal line connecting all the dots. Is that okay?
Yes. So this data is not linear.
Okay.
Yeah, it doesn't. So not all data is linear too. This data is not linear. It's actually in math, it's what you'd call a hyperbola. It's going to look, I'm pointing at the screen with my finger. It's going to look like this, like round. And that's expected.
Okay, thank you.
You're welcome. So I did mention that if your data is linear, you could put like a linear best fit line through it, I mentioned that. You can either just point the dots. If you want to connect them with a smooth curve, that's fine too. I'll teach you more about it when we're actually going to graph data like this later. But I like to start off by talking about it because it gets us talking about numbers and kind of getting a sense for the sizes of numbers, which is going to be really valuable as we talk about measurements next week. Kind of giving you a preview of how we're going to use numbers in the context of science as compared to your math class.
Thank you.
You're welcome.
I have a question about increments. How would we find them?
So there's a couple of ways. So the way that I teach you, that's kind of like a recipe, a formula, a way of doing it is like this. Kind of choose a range that covers your data, and then try to divide it into however many boxes you have, like this. So we chose the range here 0 to 12 for 2 reasons. One was because we knew we had 12 or 13 boxes, okay? And the second is that our number 2 is fairly close to 0, and 0 would cover it. It would be less than 2. And near the top, our number is 10.7, which is fairly close to 12. And if I go 0 to 12, I can divide that into 12 boxes. So what you do is, keeping in mind how many boxes you might want to use, like 12 or 13 here, or maybe 10 would be okay too. Figure out what range you could have that could be easily divided into that. So here, going 0 to 12 means we can very easily divide into 12 boxes. That's the kind of like formula recipe way. The other way is just to kind of start to take a guess, like, you know what, I'm looking at this, I have 12, 13 boxes. If I count one by one from 0 up to 12, that should cover my data, right? So that's the other way you can do it. That's not like a recipe like I gave you at the top, but it's a good way of kind of guessing. So I'm going to try it. And you should do this with pencil, of course. I'm going to try 0, 1, 2, 3 and count one by one, and that would work. Similarly here, you could try that same strategy, but with hundreds, because it looks like, you're going up by hundreds or approximately 100s. Of course, you don't want to make the labels exactly the same as your data points. That's a mistake that a lot of people make. So you might just think, what if I try going by hundreds, starting at 0, since my first value is close to 0. Okay, 0, 100, 200, 300. That can work out if the numbers, look very nice like this. Otherwise, that's why I taught you the other way. If, you know, it's not as easy to figure out what your division should be, just find a range like we did here, 0 to 1300, which is a range of 1300, and try to divide it by how many boxes you've got. So we could have or sorry, those would have given us 130 per box, but 130 isn't as nice as 100. I knew I had 13 boxes, so if I divide 1300 by 13, I get 100. And so we are doing a bit of guessing here. The reason why I give you kind of a, you know, a mathematical method is because when the numbers aren't 1 or 100, you might be wondering like, okay, how am I going to decide what my labels should be for this one, right? So I could try to go, you know, 0.1, 0.2, 0.3, 0.01, 0.02, 0.03 like this, where my range was here, but that might not be immediately apparent to you. So that's why I give you this kind of general strategy where you want to get a nice round range first, and then you can divide it into a certain number of boxes. So vertically, we have 6 boxes here. Dividing by 6 is generally not easy. So that's why I put 5 here, 5. Maybe we'll use 5 of the boxes, not 6, because dividing by 5 is often easier than dividing by 6. It gives you, you know, smoother numbers to label with. The same is true for like 11 and 10 here. Dividing by 5 and 10 and 1, or you know, you wouldn't have one box, but dividing by 5 or 10 or 20 or, you know, whatever is a lot. It gives you a lot smoother numbers a lot of the times than dividing by like 7. You know, not a lot of things divide easily by 7. So here, when we're choosing our range, we just want to make sure that we cover our data, but that we don't go too far from the ends. Okay, so like here on my low end, I chose 0 because it's pretty close to 0.202 compared to our high end, which is like close to 1. So choosing a range of 0 to 1 here is very nice because 1 can be easily divided into pieces. And it covers our data from the low end, not too far away at 0, up to the high end, not too far away from 0.936. Then I divided that into 5 boxes, which gives me 0.2. So if you can't just guess at it, if you're trying to guess, so what should my marks be here? You know, should I go 0.1? You could try that, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, but you'd get to 0.6 here, and then you'd be out of graph paper. And so you wouldn't be able to get up to 0.936 like you need to. So then you could try 0.2, 0.4, 0.6, 0.8, 1, 1.2. Okay, that would work. So if you're just guessing, that's the way you might guess. But if you do it in this fashion like I did here, making a nice round range and then dividing it into boxes, then you don't have to guess. But either way is fine. I think that guessing to what I should divide this, what boxes I should have for this one, would be particularly hard for most intro chem students. So what I say is, again, make a nice smooth range out of this. On the low end, this looks very close to 0. So let's call the bottom end 0. And this one, I want to be just higher than this with a nice round number. Well, again, 5s and 10s and things like that, those tend to lead to nice round numbers. So I might go 0.05. That's just bigger than 0.048. And then again, I chose to divide by 10 boxes because dividing things by 11 is not usually going to give you nice round numbers. So we divide by 10 boxes and that gives us 0.005 for each box. Okay. Or for every 2 boxes, that's 0.01. So the steps are determine how many number of divisions that you might have available and might want to use. So here we have 11 available. We might want to use 10 because dividing by 10 is easy. Here we have 6 boxes available. We might want to use 5 because dividing by 5 is usually easier. Then I gave you some example numbers here. In these numbers, I decided to have my range be 0.4 to 1.5 because that gives me 1.1. Okay. and that's very easily divisible by 11 boxes. It just so happens. But if you chose a range here of like 0 to 1.5, then not bad. You could divide that by 10 pretty easy too. And you wouldn't be able to divide it by 11. So just choose a range that's nice and round here. So on this one, it was a little bit easier to choose a range for these. Here, I wanted to give you that sense that you're not always going to come up with a nice range that's perfect, right? So here, my range of numbers exactly is 92. Not easy to divide by anything. But if I go from 0 on the low end to 120 on the high end, that gives me a nice round range. And I happen to be able to divide 120 by 6 very easily. So I did divide it by 6 and made it 20 per box. So there's a little bit of guesswork, which is what makes this challenging for students. Fortunately, most of the time we've got computers to handle this. But I find that my students read graphs better, which you're going to encounter in the next section, when they actually have to try to make one for themselves from scratch. And so that's why I start with this one. Did that help, or did you want to follow up on that question?
If I'm not mistaken, it's so basically it's like the amount, like the number per box. Is that correct? I kind of got lost.
That's what you're trying to get. What is going to be your
Okay.
value for every box? And so this involves, a little bit of a process, because you got to know, well, how many boxes am I going to use about? Because you're going to divide that range that you have into a certain number of boxes. So that's the first thing I did, was kind of think, how many boxes am I going to use about? And then I choose a range that will include my numbers, but will not be too far away from the ends. Like this is a good example here, 0 to 1. This includes my numbers, because 0 is less than my lowest number, 0.202. 1 is higher than my highest number, but not by too much, because you don't want to have like this huge range, but your data is only in this little space, right? So that's what and that's what you do. And just try to choose a range that you can easily divide into pieces. 0 to 1 is great, right? Because that's pretty easy to divide into pieces that are going to be very nice, like we have here. So yeah, the whole goal of this is to figure out what you're going to label the boxes as. And that's why we go through this process.
Thank you.
You're welcome. Other questions here? Okay, I'm going to stop the recording and I'll put this up on YouTube for you guys.